quick motors, let's do 17 and 18 real quick. We'll double Dutch. Okay, 17, refer to the motor nameplate shown in 230.108, the smallest branch circuit conductors that can be installed between the two-pole circuit breaker. So when we're talking a two-pole breaker, we know that's going to be a single-phase motor that can be reinforced with the fact that it says single-phase motor on the nameplate. In a 240-volt three-phase four-wire panel board are what gauge? Okay, remember we will be using the FLC from the back of Article 430, and specifically that lives inside of 430.248 for single-phase motors. Okay, we're talking a 7.5 horsepower motor at 240 volts. Okay, so let's go find that real quick. Back of the article, 440, I will just go backwards from there to my 7.5 horsepower here at 230 volts. Remember that does include the range up to 240. Okay, as a 40 FLC, full load current is going to be 40 amperes here for this bad boy. Okay, so I have two calculations that I'm going to need to do here. I have the conductor calculation in 17, and I have the overcurrent protective device in 18. So motors, unless it specifically tells you not to, we will apply the continuous duty 1.25 to those conductors. So I will just take that 40 times 1.25, and I will get 50 amps for my conductors. Okay, pretty easy, pretty straightforward. Then I'm just going to cruise over to our Holy Grail article. As usual, 310.16. I will look in that 75-degree column, and I will find me a conductor that is good for 50 amps, and it looks like a number 8 fits the bill perfectly, right on the nose, in fact. Okay, so that is a number 8. Deal. Bravo. Okay, the next question is basically just asking for the largest two-pole circuit breaker. Okay, so I'm going to take that same 40 FLC that I already calculated, and we're going to figure out what the multiplier is for a circuit breaker. Okay, your overcurrent protection section inside of 430 lives in 430.52. We were briefly in there a little bit ago, and we've been in there plenty throughout the year. So let's just go take a quick look at what that looks like. That table looks like that right there. Again, we are in single phase motors, and I'm talking an inverse time circuit breaker, or a circuit breaker, basically your standard circuit breaker, and that's 250%. Okay, so just multiply that by 2.5 for 250%. So let's punch it out. 40 times 2.5 is 100 amperes. So I will take that number 8 and I will put it on a 100 amp circuit breaker. Okay, and I will feel great about it. Bonus points. What's the EGC for this one then? It's a number 8. EGC, also a number 8, right? Okay, we could check that in 250/122. See if it works for 100 amps. And also, it's not required to be larger than the circuit conductors, so that seems like it's appropriate. I think it'll fit both criteria. Check it out for yourself. So that's those two.